So in this video, we're going to take a look at numerical continuous data. And remember the difference between continuous and discrete data, that continuous data, we're going to assume that you can't get 2 points that are the same. Okay, so remember someone's height, for example, might be 168.72 centimeters, and another person's might be 168.74 centimeters. We're going to assume that they're never going to be the same, because if we wanted to, we could go down into the hundredths and thousandths of a centimeter and separate them that way if we wanted to. Remember, with discrete data, it's quite easy to get two that are the same, right? We use the jelly bean example. It's quite easy that two kids have eaten the same number of jelly beans or eaten the same number of pieces of fruit, right? That's quite plausible. But here with height, we're going to assume not so much. And we get continuous data. Let's look at an example of how we're going to organize this continuous data and then display this continuous data. And we're going to need the class interval stuff that we learned in the last video, or we sort of saw in the last video with discrete data. So let's take a look, our example being the height of a flower. And it might be a sunflower. And my data set that I'm going to get from this is I've got one that is 5.6 centimeters. I have another one that is 13.2 centimeters. I have another one that is 16.9 centimeters. I have one that's 27.4 centimeters. One that's 29.3 centimeters. And I have one that is 34.6 centimeters. So see here how none of these are the same, okay? It's not like discrete data where we can quite easily get two that are the same, okay? And remember, we saw it with the discrete data that when we have large sets of discrete data where it's unlikely that we have two that are the same, we have to introduce our class intervals. So that's what we're going to do here. And where we're going to break it down, I would say let's go from sort of 0 to 10, and then from 10 to 20, roughly 20 to 30, and then from 30 to 40. But the problem being that we can't have these two 10s, because then which one do you put it in? So let's go from, as we did before, 0 to 9, and then let's go from 10 to 19, 20 to 29, 30 to 39. Okay, but now the problem is, what if you had 9.5? If you had 9.5, it doesn't have anywhere to go. So the trick is to write the class intervals, and I'll do them down here. We want our height, we're going to include 0 at this end. So that's what that equal sign under here means. We're going to include 0, and then we're going to go all the way up to 10, but not including 10. So 9.99999 would go into this category, but not 10. Because we're going to include 10 into this category, this interval. And it's going to go up to, all the way up to, but not including 20. And then we're going to go the same thing. And then we'll do it one more. 40. So why did we not have to do this for discrete data? Because with discrete data, we never had a 9.5, right? It was either 9 or 10. So we didn't have to worry about this problem that we're on this continuum, okay? And that this can fall anywhere on our continuum. So how can we plot or organize this data? We're not going to plot it yet. We'll organize it into a tally and then a frequency. So setting up our table as so, let's have a look at our data set, which is up here. So 5.6 centimeters, that falls into here. 13.2 falls between 10 and 20. 16.9 falls between 10 and 20. 27.4 falls between 20 and 30. 29.3 also falls between 20 and 30. 34.6 falls between 30 and 40. And I'm going to add another one in here just to show you what I mean. Let's say it's 10 centimeters. So where are we going to put 10 centimeters? Well, 10 centimeters is going to go into this column because it's equal to 10 goes into here. Up here, we can only go all the way up to, but not including 10. So 10 falls into the second column. And then let's frequency this as so, okay? So just counting up our tallies and making them numbers. And now we're going to plot this. And we plot this. I'm going to go down here. We have our interval and our frequency. And our frequency runs as high as 3. So we'll go 1, 2, 3 like that. Okay, well, that's a 2. Kind of looks like a 1. That should be a 2. And then our interval from 0, and instead of writing height, I'm just going to put h. And then I'm going to do the same thing here. And then the same thing here. And then the same thing here. Now this is kind of one way of doing it. And then we can get these columns. So doing it as we did before. So here we have 1. And then the next one is 3. So this one here is 3. And then this one here is 2. And then this one here is 1 again. But why do it like this if we can just put it all along one continuum, right? So let's, rather than having the gaps between our columns, let's do it as what we call a histogram, which is where we have just one continuum. So we go from 0, 10, 20, 30, and 40. Okay, and now what we're going to do, of course, 1, 2, and 3, we're going to plot this so that they're touching, okay, because it's all one continuum. So let's plot it as if they're touching, like this. This is now what we call a histogram. And this is the best way to display continuous data. So it's very similar to the way that we displayed discrete data, except now we're kind of taking these intervals and then we put them together so that they're touching each other because we're running on one continuum. And we call that a histogram.